Hello and welcome.
Oh,
Hello?
it's only me? Oh, hello. Hello. Where are you locate?
Switzerland.
Oh, so it's about evening or
No, it's very early in the morning. It's like a little bit 6:30 in the morning.
okay. Thank you for coming. Okay, today we are very happy to invite Andrews to join our session. And later he also a Java champion, and he has many related experience. So later he will just say hi, and then he will start his section. So maybe Andrews, you can just say hi to everyone.
Well, hello, Vincent, and hello, everybody else. It's quite an experience being able to engage and share knowledge with the Taiwanese community for me. This is, I think, my second time participating in such an event, but I'm very happy to be here.
Okay, thank you. So let's start our session.
Today we're going to talk about building modular applications with the Java Platform Module System and Layrry. My name is Andres Almiray. I'm currently employed by Oracle, and I love open source. And one of the things that we do inside the company is create products and projects in the open. If this is something that interests you to learn more about what we do, well, please just reach out. I'll be very happy to talk to you about those things. Now, today the topic is Java Platform Module System. You may know this from a previous name known as Jigsaw. And the project started around late Java 6, early Java 7, so that's quite some time now. And it was finally released by the time where Java 9 came out, close to 4 years ago. It was designed to break down the JVM monolith because, well, the JVM is a huge piece of technology. And adding new features and keeping it snappy, well, requires quite a lot of effort. If it were to be able to break down into smaller pieces, then these efforts will be reduced, and the features will be much quicker being able to be added to the platform. Now, while the designers and the architects were working on the code, they saw that what they were doing could be applicable to user space, to our space, to the developer space. And that's how we got the module system in Java 9. The promise is that once you make use of the module system, then you have better encapsulation for your code base, and you have better design foundations so that your consumers, the developers that consume your code, will have a much better time dealing with the APIs that you produce. Now, there have been some concerns, and if you have already used the platform module system, you may have encountered a few of this. For example, it's known that you can only have, there's only one version of the module. You cannot have multiple different versions of the same module with conflicting APIs or binary incompatibilities. Well, because, well, there's only one version of the thing. You also cannot add modules at runtime because modules are verified at compile time. So if the code compiles, the modules get assembled and the application runs. And once it's running, then you cannot add or remove modules. Also, supposedly, we have to modularize all the dependencies in order to reap the benefits of the module system, because that's how we can tell if we can consume a package or if it's private. So that's how we can tell if I have access to a particular service, or if a package is open for reflection or not in the class. But of course, it's the Wild West and everything goes. But in the module path, well, we have rules. Now, for these rules to take effect, we need a module descriptor. You can still have an application that is somehow modular or semi-modular or hybrid, but not all the benefits from having a fully modular application will be available to you unless you have all modular dependencies. It's also hard to map dependency coordinates to module names. So by dependency coordinates, I mean the group ID, artifact ID, and version, or also known as GAV coordinates from Maven, into a module name. So we are able to find very quickly what particular version is there for, let's say, a dependency like log4j. and we know that log4j has a group ID as org log4j. But do we know which jar contains a particular module? And this is the hard thing to do. And finally, well, if you happen to have more than one package with the same name, in two modules, even if one of them is not exported, we're going to have a bad time. This is known as split packages. This is something that is disallowed. There are ways for you to patch jars and patch modules to try to get around this, but that's kind of more like a hack and a stopgap solution before everybody moves into the module system. Now, the Java module system provides a series of APIs and classes, and one of them is called module layers, which we could leverage to solve many of the issues that we just saw in the previous slide. Now, the Java doc for module layer says supply a configuration object that tells where to find the modules and the names, and you can create at least one class loader or multiple class loaders. And from these class loaders, you can load the classes and launch the application. And because of the name implies layers, you can have multiple of them. You can have a hierarchy of layers, each one of them providing isolation for the classes within that layer. So that if we do things right by exporting interfaces and exporting services, then all these layers with isolation should be able to work without any problem. Here is how the API looks like for the module layer. Basically, how you could bootstrap an application in a modular way if you want to do it by hand. So you have to find the jar file somewhere in your file system, then create a configuration object where you supply the names of the modules, no longer the gap coordinates, not even the file paths. And from that configuration, we can bootstrap the module layer, and from the module layer, we can load classes, and off we go. Now, this API is not that bad. I mean, for a handful of modules, it's quite straightforward. But if you have a big application that is fully modular, then you will see that, well, things start to get a bit hairy. Say, for example, you have an application like this. It's very simple. You only have 5 custom modules. So it's the app module that depends on foo and bar. Foo and bar depend on a common module, which is the log4j API. So far, so good, because that's the same compatible version. But notice that foo depends on Gritter version 1, and bar depends on Gritter version 2. If you try to compile this, the compiler will tell you, hold on a second. First, very likely you have split packages, and second, likely because there's a major difference between 1 and 2, there will be binary incompatibility. So definitely, I'm not going to allow this application to compile. So how can we solve this? This is where Layrry comes in. So Layrry is an open source project. His creator is Gunnar Morling, fellow Java champion, working from Red Hat. And this is the same application, but using the Layrry API. Notice that we have a series of layers, so it has a fluent interface design. And instead of listing the module names, we list the gap coordinates of each one of the dependencies, which will supply the modules. So what will happen is that Layrry will use the Maven dependency resolution mechanism to locate the jar files, download them if needed be, if they are not cached locally, and assemble the application using the different module configuration. Notice that foo depends on version 1 of Gritter, and bar depends on version 2 of Gritter. And this application will still be able to work because Gritter version 1 is isolated in the layer foo, and Gritter version 2 is isolated in the layer bar. And neither of them are in conflict in this case. Now, Layrry happens to be just a tiny abstraction on top of the Java platform module system, which again, you can still do things by hand if you want to, but Layrry gives you some benefits. You can have external configuration. So if your application starts to grow and you see that this fluid interface design is not for you and there's duplication with what you put in your build file, so POM.xml or bit.gradle, you can externalize the configuration. Now, here is the same example that we saw before, but using a YAML file. If YAML is not your thing, you're like my friend Bruno Borges, you think that YAML is not a very nice format, then we could use other ones like TOML. In this case, Bruno is quite happy with the TOML format. Or it could be XML or JSON. It's pretty much the same from the point of view of Layrry. It's just another external configuration file. Now, there is still a little bit of repetition in terms of the version number. So if you update the version number in your build file, you will also need to update the version number in this external configuration file. Now, there is a way for us to parameterize the external configuration file. Now, here is another example. This is a JavaFX application that we'll see in just a moment running. Here we can see that there are some variable placeholders like a JavaFX underscore version or project underscore version. Now these variable placeholders will come from a secondary configuration file, which happens to be versions.properties. The name can be anything you want to, it's just that the format has to be a properties file, where each key value combination, the key is the name of the variable and the value will be the actual version that we would like to use. So when you launch Layrry, you can combine these two external configuration files, and that will allow you to bootstrap the application. Speaking of launching, how do we launch an application using Layrry? Well, there are a handful of ways. You can go into the release page. The latest version is 1.0.0 Alpha 1, released back in January of this year, of 2021. That's when about this snapshot was taken. So there is that a jar file that contains everything. That's an uber jar or fat jar, well, the dependencies, or there's a tar.gc or a zip file. So just download those things, configure your path, and then you can launch the command. So if you go with the jar file, which again is an uber jar, just execute the jar file and pass any parameters like the configuration file, layers config, or the properties file, properties. Or you can use SDK man, this very popular package manager, where you just tell it SDK install Layrry, which version, if there are more than one version available, it will eventually you'll see, and then just pass in the parameters to the Layrry command. Or you can also use jbang, another way to launch jar files or single source Java files as if they were script files. Now you can see that regardless of how we launch the Layrry command, we still have access to the same configuration flags like layers config and properties. There is another feature that saw me into looking further into Layrry, which is plugin architectures. Basically, this is the option for loading or unloading modules at runtime. Layrry exposes an interface called Plugin Lifecycle Listener that you as a developer has to implement. When you do this, you can react when a plugin is added or when a plugin is removed. Typically, you will do it in this way. You will use the service loader facility that was available since Java 6. The My Service type is a type that is under your control. It's an application type. And once you load all instances and you filter it by the current layer, the layer of the plugin, then you have the new object, the new instances. And there will be a similar way to do this when you unload the plugins. Now let me show you a quick demo. I do have an application right here already. What I'm going to do is, it's a Maven-based application. This is the JavaFX app. So what I'm going to do is build it and publish to my Maven local repository. This build generates some configuration file in Toml, some plugin files here, and two directories. So the plugins directory is empty, and the plugins prepare, which is outside of my application, contains the jar files, the plugin files. If I showed you the configuration file, it looks pretty much the same as we saw in the slides. It's just external configuration for a JavaFX application, and it has a plugins directory right here. We'll see that how it comes into play in just a moment. The other file that we can have a look at is the versions, which is just key values for those placeholders. Now, I do have Layrry installed. Oops, that's not the command. There it is. So I have version 1.0.0 alpha stable and my current snapshot. So I'm going to use alpha version. Now I can say Layrry run the following layers, which we know is in the staging layers Toml, and use the following properties, which will be the staging versions. And I'm going to run it in the background. Now this will pop a window that's currently empty. Now, let's look again. The plugins directory is empty. And what I'm going to do is from outside of my application, I'm going to copy from staging plugins prepare. Let's copy this file as a jar file, and let's copy it into plugins directory. And it also happens now we have the current time zone and the current time in Switzerland, where I'm streaming from. And if I have a look again at the plugins directory, there's my jar file. Okay, let's do more. Let's copy from staging, plugins, prepare. Let's copy this one. Now let's copy the zip file and put it into plugins. And now we got another widget that is also animated. And let's copy the last one, plugins prepare, tile, and this is gauge, and let's copy the tar file into staging plugins, and we get that one. So you might be wondering, why do we have different formats? Well, the jar file contains just the single plugin. The zip and the tar.gc files can contain your plugin plus any additional dependencies required by, say, plugins. Now we can do the following thing. We can remove, while again the application is running, from the plugins directory, let's remove the widget in the middle. And it's gone. And now let's remove the other one. And it's gone. Now we can quit the application and run it again. Remember that I still have the clock plugin in the plugins directory. So when the application is launched, I see that plugin already started. So this is it. I now have a JavaFX application where I can load and unload new behavior, new UI, just by having my custom plugin lifecycle listener. And this is what Layrry provides. So there are more things. So Layrry will download dependencies from Maven Central, but if you want to constrain the resolution to just local files, not even remote repositories, you can do so. So we support two different formats or two different layouts, and you have to explicitly say, I want to use the flat layout or the default layout, and this is the path to the directory. So the flat layout looks like this. It's just one directory with all the jars, or the default directory where you have a series of paths where you can eventually drill down all the way to the jar file. You can also have remote layers. So I show you using a layers file that is locally available in my computer. But if I want to host that layer file in a remote server and tell Layrry to download that file and resolve all dependencies as needed be, that can also happen. You can have a mix of local dependency resolution and remote dependencies. You can have the layers file or even the properties file. Both of them can be remote or can be local. You have combinations. But what it has to be, that's a limitation right now, is that all plugins, like the ones that I show, the clock and the tile and the other tiles, they have to be definitely available locally. Another thing that could happen, especially what happened in this JavaFX application, because we are loading and unloading classes, we could have memory leaks. We had a problem with this particular class and with this particular application, the JavaFX, and we ended up inspecting using different tools. In this case, we're using JDK Mission Control to figure out what is the current state of the application. Layrry will trigger Java Flight Record events, JFR events, whenever a new layer is added or when a layer is removed. And those are the events that we're currently looking at this particular screen. Now with these, we're able to drill down that we have some classes, these plugin classes, that were loaded whenever we add a new plugin file or when we remove a plugin file. We expect them to be unloaded. But by just looking at the different events that were happening, we ended up looking at that the plugin classes were not being unloaded. It so happens that there was a background thread running that kept references around. So even if we thought that we were unloading classes, those were still lingering there. And that's how we were able to tell that, well, it was a simple fix. Just shut down the thread whenever we do an unload. This is code that you have to put in your application. But thanks to the JFR events that Layrry publishes and the different tools that you have available in the Java space, like Mission Control and flight recorder, then you're able to drill down into these things. Now, for the future of the project, what can we see? Well, we will eventually distribute more binary distributions. So right now we distribute via SDK man, but if you like to use Homebrew or Snap or Chocolatey for OS X, Linux, or Windows, then we will eventually provide binaries for those. There will be perhaps another way where you can have self-contained distributions. Think of it as a zip file that contains the dependencies, the data file, and the versions, and this zip file is executable. It's another way for you to launch the application. Another thought that has been going around again, trying to remove that duplication from in this case, for the POM XML file, is that what if the structure of your Maven project will be able to be used to generate the external configuration file, the layers YAML file, for example. And we will definitely provide more JFR events whenever they make sense. Or if you tried out this project and you find that there's something that is not working, or maybe there's a missing feature, well, let us know. And as a matter of fact, this is where you can look at things. The first link is the URL for the project. And the second link contains a handful of examples. The JavaFX application that we saw today is available in the second link, so you can run it yourself. It has a README and everything that you need to do in order to get started. We have a couple of blog posts stating what is the basis for the project, and how to use the plugin architectures, and the investigation that Gunnar did in order to detect the memory leak, an announcement for the first release, and well, they eventually will have more content for you as well. So if you have not worked with open source before, just as working with Layrry, let me tell you, it's quite easy. You find a problem with anything that we saw today, or any other open source project out there that you may be using in your daily work, file a ticket. That's it. If you have the time and the passion, you can send code, but at the very least, just create a ticket, engage in a conversation with the team at the other side. Let them know you're using the project. Maybe there's a missing feature, maybe there is a bug. Just let them know how they can improve the particular project. And that is everything that I have for you today. I hope that you like it. I hope that Layrry will help you craft and create modular applications, and that you can jump, if you have not jumped already to the Java Platform Module System, then Layrry can help you get started. And thank you very much.
Okay, thank you. What a great section and cool slogan. Keep calm and open source. Okay, and now we have a Slido, and I think maybe it needs time for them to think their answer question. But later we also have the gather town Andres. You already entered it?
Yeah, so I got the link.
Okay. Maybe we have some partner, and maybe you can join us, and just if they have some question, and they also have, maybe they want to do some communication or do some feedback, we will do more activity at that interest. Okay.
Yes.
Cool. Okay. So I think for now, no one have the question. So okay. So thank you for your session.
Thank you very much, Vincent. Thank you everybody else for being here, and keep enjoying COSCUP and RubyConf.
Okay.